So in our project we have worked up with the final problem statement. Is it possible to make people in front rows medium-sized venues take part in a crowd-controlled computer vision based activity while they are waiting for a concert to start? The image processing part of this is the crowd-controlled computer vision based activity, and the question is how we can make a crowd able to control this activity by computer vision. And there was many methods to do this, and we have chosen color detection to do so. And now we will move further to explain the code behind our color detection. And first of all, we got several variables of importance. First of all, being the different kind of containers which can contain the images, the information about that. And we got the video grabber, so we can have the video input on the frame. And we have the off texture, which is also very important, so we can print the image out in the frame. And we have different heights and width of the frame, so we know exactly how wide and high it is. And at last we got the container for the colors, which can separate the color channels into RG, red, green and blue. And now move further to the actual code here. Well, first of all, we grab the image, put it inside the frame, check if it is so, and if that's the case, then we can run the code. And well, first of all, we put the pixels at the frame we are at in the moment, the frame we got from the camera, put inside the container the pointer called pixels. And these pixels, the information are put inside the data called the video inverted, so we can print out an unfiltered image of what the camera records. And this variable called pixels is very important, which we will use further on. Which first of all, we will put it inside the color detection, which will be explained further on now.
So, to make it easier for us to keep a single color in a specific section of the image, it has been split into 3 different segments as seen in the first part of the double for loop. To be able to track a specific color, we have set up a color filter. This has been done by splitting the input image into 3 different color channels, red, green and blue. After the image has been split into these segments, the image's hue, saturation and brightness is called. An if sentence has been made to basically say if the colors in this image are within these parameters, make those colors completely white, otherwise make them black. These parameters are as seen on the screen here. The hue defines the color of what is going to be tracked. In this case, it is blue. Using the upper framework's documentation on color, we were able to estimate the value needed to track this particular color. In this case, the value needed for the hue was somewhere between 150 and 165. The saturation value defines the intensity of the given color. Brightness dictates, as the word implies, how bright the color is, or more accurately, how light or dark the color is. The last section here combines the divided up sections of the input image onto an output. But this time it will only output the blue channel, as it will be the only color present in the image. By doing this, it enables us to see only a very specific color range in an image. The following code for tracking green and for tracking red are very similar. The only thing that has been changed is where the camera is looking, or which part of the image that is being looked at, as well as the values of the hue, saturation and brightness.
So by those 3 parts of the camera, we now have a fine color detecting image, but we need to put them all those 3 together in order to put them inside the OpenCV gray image, which we will need in order to detect blobs. So in order to do so, we then put our video division data inside the video combined, which combines all three parts of the image, which we have found in the video division. When we combine it, then put it to the gray image, the OpenCV image. In here it is dilated in order to give us some bigger blobs and to erase eventually small black spots inside the blobs. And then it is thresholded. And upon this gray image, we find contours which are bigger than 20 pixels and smaller than a third part of the image. And we can track up to 200 of those blobs, and we are able to find blobs inside blobs. So to say, every time it can detect any white in the image, it will say, oh, there's a blob, we detect that. And then we just load in our data from our video invert, the unfiltered image, and put it onto our frame. And further on, we have here, and here we have our binary image drawn. Right now it's commented out, but in case when we run the program, it would be uncommented anyway. And that's pretty much it, how our color detection works. And then according to the amount of blobs, we'll do some action in the game. Yay! So here's the example of the working program. You can see it detects reds, green, and blue.
What? You drink it in?
It's okay.
So it's just